Hi guys, today we are going to discuss linked list. So linked list, as the name suggests, is something related to links. We can see in the name itself that the word link comes. So it is something related to links. If we go more formally, it is a linear data structure. It is a linear data structure. A linear data structure where every element itself, every element itself is an object. So linked list is a linear data structure where every element itself is an object. So before explaining this whole statement I just wrote, I wanted to go to the disadvantages which we were having for arrays, because of which we came to linked list. So disadvantages, there were two disadvantages mainly. First was there was an issue of fixed size. So what was having is uh, in arrays, what was happening is whenever you are going to put some elements in array, you need to have a fixed size. Suppose you want to put 5 elements in an array, then you need to have a fixed size array of 5. Then you will be putting those elements inside. Okay, but there was no way, there was no dynamic way by which we can increase that size. Suppose I want to put one more element in the array, then what I need to again do is I need to go for an array of length 6. I need to create that array. Then I need to put those previous 5 elements and the extra element which I wanted to put. So this is the issue which array is having. We need to have fixed size declared first, and then we can proceed with inserting elements. And the second issue which we were facing with arrays was of insertion and deletion. We are able to do these things, but these were costly, which means costly in the sense, suppose I'm having 1, 2, 3, 4, 5. These elements I'm having. Okay, uh, I want to insert, suppose I want to insert 0. Wanted to insert 0 in this array. So this array is ARR. Okay. So I want to insert 0 in this array and I want this to be sorted. So basically I want to insert 0 at the first place. What I need to do is I need to like shift all the elements to the right, which means firstly I need to create an array which should be of size more than this, one more than this, that is it should be of size 6. Then I need to shift these elements by, then I need to put array 1. So it will be like this. So insertion is in this case is like shifting all the elements to the right and then placing 0 at first place. And if similarly we go for deletion, then for deletion we need to remove, suppose we want to remove 4. Then for removing 4, after removing 4, we want all the elements to be sorted again. Then what it should do, it should like 5 should come at the place of 4. It should be 1, 3, 5. So that is, these two operations get costly when we wanted to do them in arrays. So these were the advantages which linked list overcame. And in linked list, there is no issue of fixed size. There is no issue of fixed size in the sense we can insert an element or we can delete an element on the go. So there is no issue with that thing. There is no size issue in linked list. You can create an object and link it to the linked list already available. So there is no issue with that. So linked list overcame these two problems. Now we should see. I just told you the uh, like overview of linked list. Now we wanted to see how linked list looks. What is the structure of linked list? So I initially I told you that it is a linear data structure where every element itself is an object. And what type of object every element is? I wanted to show that to you. So I already created a diagram for representing that, which shows this one. You can say not this one. Okay, Control Z. I want to have shapes. This is that object I was talking about. So this is an object, and similarly, this can be similarly this is an object, and the last one is also an object. So what is happening in this case? What is happening in this case? This one is also an object. What is happening in this case? The structure is simple. There is no issue with the structure. The structure is simple. This is an object. It is having its address of the object itself is address 0, and that object is having properties, data, and the address to other object. You can say node in this cases. These objects we call them as node in linked list. So for this object we are having data and address of the other object. You can say node, address of the other node, which is address 1, and it is storing it. So basically it is linking these two things. It is linking this address to this address. Again, this node is having address for other object. Address 2 it is storing, and it is having its data. So this and this are getting linked again. Because of this, we named it as linked list because there are links present in between nodes. Okay, so this is the basic structure of linked list. Now I can show you how a node looks and how a node looks in a pseudocode. I can create a text box for it. The text box. Create a text box for it. So node will be creating a class node which shows the structure of node, how a node looks. Okay. So suppose the data is of type int. Okay. The data which we are having is of type int. Can someone tell what should be? Suppose this addresses we are calling as next. So this address one is of the other node. So we are calling them as next. Can anyone tell me what should be the type of this next? What should be the type of this next? So the next itself is an address. The next itself is an address which is these similar to these, like these similar to these addresses. This is an address and it is storing that address. So what is the type of these object? Type of these object is their node. Okay. So in this case, the type of next should also be a node. This will be the basic structure of our This will be the basic structure of our nodes, every node which we are having in our linked list. And then later we can have a constructor to put data and next address to this, but that we can do in editor itself. I can show that demo to you online, right? If it's online ID we went to, and then I'll select Java. You can proceed with any language which you are comfortable with. So what we can do is we can have a node class, and that node class we can use to create our linked list. So I'll be creating a node class, private class node, and data is there in the node. You can see data is there in the node and address is there in the node. So we are creating the structure for our nodes. So data is there, and next is there. We can create a constructor also. Okay, so constructor is data into data and node. Next dot data equals to data, and this dot next equals to next. So this constructor will be, this is a parameterized constructor. It will be giving values which we pass to our object to this node object. So next and data will be given to it. Now what we will do is we will try to create a node. So node, you can just say in new node. We should pass the values which we want to, like data. We wanted to have suppose 13, and the next. For the current node, I don't know what it should point to. What should be the address of other node? I'm not having it right now. So what I can do is similar to this one, like similar to this node. I'm right now not having the address of my node. Okay. So what I will do is I will pass that next as null for now. Okay. Then what can I do is, if this node is created, I will just try compiling the code and I'll see that this much code is running fine on it. If it is running fine, then we can create non-static variable. This cannot be referenced from a static context. Okay. So the class should be static because we are trying to access it from the main static method. If the code executed fine, then what we can do is we can have one more node, and even you can say new node can give 7 comma null for now. One more node into equals to new node 9 comma. For right now every single node is not linked to other node. They are just having a data, and address is null right now for them. So now we are going to link. So this is our, suppose this is our last node. Okay, this is our last node. This all these are this can be, we created these nodes, or we can, what we can do is, now we're going to link them. So we should find a pattern we want, in which we want to link them. Suppose I want to link them in this way: 13, 13, 7, 9. I want to link it this way. So what I should do is, there is node 13 there. Okay. In the address of 13, there should be 7. So 7 is this one. It should store n1. Okay. Fine. 7 is n1. It should store the address of 9. It should store n2. Right? And then 9 is not having address, 9 is not pointing to anything, so it should store null. It is fine. Okay, so as we are using these, so n2 should be declared at the top. Okay, because n2 we are going to use, and n1 should be declared before it also, because n1 we are using it here. Okay, so n2 we declared and we are using n2, fine, and n1 got created. For n, we are using n1 and n1 got created. Okay, so now it will be creating this linked list. We can check that by looping to the list. So the method to loop to the list is simple. We will be having a node temp, okay, equals to, which we will it will point to the first node of our linked list, that is 13, and 13 in this case is n. Okay, now what we will do is, we will try to iterate our linked list and try printing every element one by one. Okay, so temp, until temp not equals to null, what we did is, we are having in temp, we are having the address of our first node, and then we are trying to iterate. We will iterate until the address for the current node, the address the current node is having is not null. Okay, so we can print it, system dot out dot print, we can say temp dot data. Yes. Okay. This much is done. Then we can say temp equals to temp dot next. So what this does is, this takes our temp to, from 13 it takes to 7, from 7 it takes to 9. Otherwise, if you don't, it is similar to when you do a loop and you give for some integer you are using it, you give I plus plus or I minus minus. It is similar to that. Temp equals to temp dot next. Now, if you run it, it will print this linked list. Take some time to run. Okay, it is showing 1379 and 1379 is there. So it is fine. This is the way our linked list behave, and this is the code we are having for our linked list. So I uh, I believe that you got a good understanding of it. So we'll stop here. Thanks.